it's like we're going up against industrial processes that have been around for like 100+ years that have been optimized by super smart engineers for the past 100 years to be the most cost effective and highest performing thing. So it's very difficult for sure. And I do agree that like government has to step in, but it's one of those things where it's not within our control to force government to price these negative externalities into our economy. So in the absence of that, working within these constraints, how do we still make progress even though it's really hard? And maybe eventually government will catch up.
Yeah, and the vibes is more stories than seminars. So,
Okay, awesome. Cool.
so yeah, maybe we could just start with that. Like, what's your origin story? Like, tell us a little bit about your company and how you got started on it.
Yeah, it's definitely a journey. So I'm the co-founder and CEO of Ouros Materials, and we're essentially a materials innovation company that is making these advanced composite materials that not only capture carbon, but also are materials that are cheaper, tougher, and more disaster resilient for the construction industry. And so we're commercializing the tech out of Rutgers University with a really well-known professor over there. And in terms of how I got into it, like I mentioned, it's kind of a journey. So I basically started off my career as a computer scientist. I had like grown up in suburban Pennsylvania, and I was always enamored by the world of Silicon Valley and like kind of all the innovative mindsets that you had over here. And so I ended up studying computer science and had always wanted to start a company, was always very entrepreneurial, loved building things. And I'd always been someone who wanted to work on really tough problems and like make more opportunities for people. I've always been very social impact driven. So I was basically really focused on how do I build up my skills so that I can make products and have all the toolkits lined up for one day starting a company. So during school, I like attended a bunch of hackathons. I like did a bunch of internships and like just built projects on the side all the time. Had like a very small stint at a food waste meal kit startup that I started with a
Where
college
where did
friend.
you where did you sorry to interrupt, where did you go to school?
I went to USC, so that's how I know Will.
Okay.
We're buddies from computer science, you know. Yeah, we were like in the same entrepreneurial org at USC. Um, so we've always been interested in the startup space, and then yeah, so I like did comp sci, was very involved. I ended up starting off my formal career in product management at Lyft. So I was part of their APM program, and I like spanned across 3 different teams. So that was really good to just like understand how like product operations and like data science and all these different areas within the company all came together to like push certain company strategy forward. But I felt like there's this kind of lack of like real world impact. And it was a little ironic because I had graduated during COVID and I was working for a rideshare company that like, you know, rides weren't really happening during COVID. So I was like, yeah, what do I like really want to do in my career and where do I want to make the impact? And because it was COVID, I had like too much time to think. So I started just like thinking through like where do I want to make the most impact. Climate had always been something that I was like deeply interested in and cared about for a really long time. I just like didn't know really where to start. But I figured like let me just start researching it. So I ended up doing this program called Climate Base and just like reading some of the classic books like the Bill Gates book, and understanding like all the different segments of where carbon emissions were coming from. And then I ended up finding like the program that funded me and like catalyzed this whole idea called the 776 Foundation Fellowship. And it had just launched. It was like this brand new fellowship hosted by Alexis Ohanian's VC firm. And they had just like spun out the foundation arm, which was able to support 20 young fellows every year to start a climate tech company or like be an activist in the space or just like full time spend 2 years on their ideas. So I just saw it really randomly on Twitter. A friend sent it to me and I applied to it. And I originally pitched something that was like completely different than what I was working on now. But it was I like had pitched like a grid optimization software system because I'd researched the electric grid during climate base, and there's so many issues around the electric grid and how it's going to integrate with all these renewable energy resources. And that's a whole different conversation, but it was really analogous to the work I was doing at Lyft. Um, so I applied to 776 with that idea, ended up getting in, which was like honestly amazing because then I had this like 2 year runway to just really deep dive into the climate tech space and like work on this idea. 2 months in, I realized it was a horrible idea. Like selling to utility companies is really, really hard. I like did enough conversations with energy startups and utility experts to figure that out. Um,
So
and
how
so,
does seven?
Just
yeah.
I'm just curious. Oh, sorry. I'm just curious. Did you ever interact with Christina at 776?
No, we were mainly interacting with Lizzie Garvin, who ran the foundation.
The only
Yeah.
reason I ask is because Christina is a friend through one of actually Arvin and I's mutual friends, David. That's his wife. So
Mm.
she's a partner at the fund.
Oh yeah, that's
So how
awesome.
does how does 776 work? Is it like you're in it for 2 years, and while you're in it, you're building the company, but they're paying you a
Yeah,
stipend,
it's
and then you can raise separately to kind of fund your venture?
so it kind of operates the same as like the Teal Fellows, or is that's what Alexis Ohanian was dreaming of, where it's like a 2 year thing where you can have 100K funded over the span of 2 years to like drop out or like quit your job and start a company, or there's even activists and like nonprofits in the group as well. So it's much more flexible and social impact based, but it was very open ended. And as long as you were working towards impact in the climate tech space full time, then you had like full freedom and operation to just work towards that goal.
So it's like when you apply, you're applying as an individual, really, with a background and with an idea. Generally,
Yeah.
like I want to be in this space, but you don't even need to be in. I have already baked an idea. It's more like I want to explore to do
Well,
something in this space.
I got lucky. I think a lot of people came in with way more baked ideas than I did. Most of the other companies coming in were uh more validated than I was and were on their path towards raising a seed round. Whereas like I came in with only a very early idea. Um and there are a couple other fellows that came in with also an idea. So my cohort had more flexibility versus I think when the program grew, they geared more towards like fellows that had more developed ideas. But it's also focused on like more of that catalytic funding stages. So you have to be like pre-seed and like haven't raised a ton of money to like get into the program because it's really meant to um, like drive that initial like 0 to 1 stage.
And do they take a cut? Do they take a percent of the company after raising?
No, they don't. It's really nice. It's just a grant. Yeah.
Wow.
Yeah, it's
Wow. I mean,
amazing.
by the way, I just looked at their website and their applications literally open on March
Yeah.
12th. So we're
Yeah,
probably
good
going to
plug.
release this pod like the day that the application's open for the
Oh yeah.
776.
That'd
So
be
it
great.
sounds like it was, I mean, I'll maybe catalyze you back into your story, but it sounds like that was important for you. The 776 Foundation is something you would
Absolutely.
have done before. Okay. So you
Yeah.
were 2 months in and you kind of figured out that what you had pitched them initially wasn't what you wanted to keep going on.
Yeah. Yeah, basically I yeah, it wasn't something that I felt like I was the right person to go solve. Like there was a couple other startups in the grid optimization software space. And at that point I was researching like different areas and like different other ideas, and I kept coming back to like this notion of like to make a lot of impact in the climate tech space, you kind of have to make like a more of like a moonshot idea around like how do we change an existing system away from using fossil fuels in the first place, and a lot of that comes down to like chemicals, materials, and biotech innovations. And so I had met a couple entrepreneurs, and at this point I'm like talking to everyone, right? Like I had met a couple entrepreneurs who didn't have like really in-depth materials backgrounds, but were able to form like a really comprehensive team and find a technology to commercialize. And at that time, I got connected to this one program called Lab Start that specifically worked with entrepreneurs to work with national labs and like universities to commercialize tech. And so that really opened up my eyes to the worlds of like IP commercialization, where you can approach these labs that have been funded by the government, like millions and millions of dollars to research like the cutting edge technologies in like concrete decarbonization or like sustainable materials or plastic recycling or and like anything related to energy or batteries. All these national labs are like full-time researching, right? So you can essentially go to their tech transfer offices and take a full deep dive into their IP and figure out like where does this IP like map to a problem in the industry and in the climate space, and then use that as the foundation of the company, and then build a really solid team around commercializing that IP. And so once I had this realization that this could be a way to start a company, I went really deep into this problem of like industrial decarbonization, like sustainable concrete and materials. And at that point, my job was like, how do I find the best technology to solve this problem? And how do I build a really, really stellar team to start the company with? So that's the foundation of Ouros Materials. I had met my academic co-founder, Professor Rick Ryman, at just like a conference in New York City. So it was a lot of luck, but it was also like I was going to everything at that point. So I was meeting a ton of people. And Professor Rick Ryman like was truly a gem because he had started several companies in the green concrete space, one of which was Solidia, which had raised like over 100 million during Clean Tech 1.0 and was like funded by Kleiner Perkins and was this pretty like fast growing company back then. And he had this new technology for this current material that we're working on, which is this advanced composite material that's like based on his fundamental research around like sustainable ceramics and concrete manufacturing. And then from there, we were able to find and recruit our co-founding CTO, Dr. Sharon Tracy, who is a very rare like ceramics concrete expert. There's not a lot of them nowadays, but she also came from like the building materials industry. So we were able to like find someone that was really like a perfect fit for the industry and technology we were working on. So that's like the foundation and the journey of how this company came to be. It's like very non-traditional, but I'm like really proud of the progress that we've been able to make.
I would love to dive in a little into the how you did the academic kind of partnership for technology. Let's
Yeah.
say that I was someone who's interested in doing it. Um, what is the professor that or the lab that's generated the technology? What are they looking for? Are they interested in the pitch? Like, what did you find was most appealing to them? How involved are they typically in the company afterwards? Like, are they just an advisory board member, or do they expect to have some sort of active role in the day-to-day operation of the company? And then, like, I don't know, what else would you recommend folks do if they're looking to do something similar to navigate kind of getting a technology out of a IP licensing agreement with a university?
Yeah, it's a great question. Um, well, so the main goal of these research labs, and I'm sure if you've ever interacted with university research or like lab research in general, is that they have a very specific goal. And most academic labs are more so suited towards like novel scientific discoveries and academic research for the sake of like a certain academic goal rather than like industry or like commercialization goal. So oftentimes you have to like sift through technologies that make sure you're like solving a customer problem and like something that the industry would be interested in versus like a novel like scientific discovery for the sake of science, right? Um, but these university labs are really just there like working on research, and that's their primary goal. And then there's the office of tech transfer, like the tech transfer office that universities have that really bridge the gap of like all this amazing research that's happening and like how do we commercialize it and gain some money back and support like future funding for the university. And so their main goal is like getting IP out the door. And so they're very open and receptive to entrepreneurs who are interested and like can bring funding and like partnership from industry and VC money to the university's research and the tech transfer office, so that they can get things out the door. So those conversations are actually like pretty straightforward. It's like kind of like you negotiate like the terms of a license, and so long as you're serious and like come with a pretty fleshed out business plan and have done your research around like the market, the industry, customers, then you can have like a very engaging conversation with tech transfer offices, and they're really happy to engage with entrepreneurs. So I would say like that's the basics. I think depending on the university and how often they commercialize tech, you have to research the terms of the license pretty thoroughly and make sure you have like good legal support. Um, Typically, you can get an option to license, which is a very lightweight way for you to hold the license to the technology and like do all that due diligence I was just mentioning. Be able to raise a bit of money and then hire on legal support to negotiate an exclusive license, which is what you need to like raise a seed round. But a lot of it is also just like researching what is a reasonable license agreement within your industry, talking to other universities that have commercial or other companies that have commercialized from that university and understanding the licensing agreement. So you're basically like managing the expectations of like what VCs would want out of a licensing agreement, what the university wants, and just generally what's best for your company.
Yeah, you're like navigating exclusivity, you're navigating
Yeah.
percent of the company ownership, that kind of thing. And some of that might end up being a standard type of VC negotiation. Like maybe it's more of a convertible
Yeah.
note type of thing where, hey, when we raise later, we'll discuss equity percentages. They kind of tend to drive in the same direction, it sounds like.
Yeah.
When did the
Yeah.
professor get involved? Was he the inventor of the tech, and therefore the tech transfer office sort of referred you to the professor, and then you met him at the conference and it sort of clicked?
Um, I met him at the conference first, and then he introduced me to the tech transfer office.
Got it. Okay. Oh, I see.
So
It was the other way around this time.
yeah, so you can take two approaches. Like one approach is say you're trying to figure out the best like recycled plastic technology out there. Um, you can say like I'm trying to solve XYZ problem around this space. And then you can email like every tech transfer office at every major university that researches the space and every national lab. And then you can set up a call with them to figure out what is in their IP portfolio that relates to that. You can also just like research. You can also just reach out to all the main researchers in the space, and then they'll refer you to their tech transfer office. So there's no like straightforward path to do it, but this is just like one way where it's like you get really clear with a problem and then you just go wide and figure out what is the best tech that is able to address this and is it available, and then kind of go from there. So that's like one piece. And then another piece is just finding, like in my case, I wasn't technical in this space. So finding like a really solid technical co-founder, either like the direct researcher that is on that technology and convincing them, or like essentially recruiting and finding someone with the background and who's willing to come on super early with you.
So where does this take you in terms of timeline? So you've sort of figured out the technology, you've met the professor, you negotiate a deal with a licensing deal with the tech transfer office, and you found a co-founder. Seems like a lot of work, first of
It is
all.
a lot of work. That's why I needed all 2 years.
So
Yeah.
then when was it that you, like, let's say like you found your technical co-founder, where does that take you in terms of when was that?
So we brought on our amazing CTO, Dr. Tracy, about a year ago. Our first project together was really intense. It was the DOE, like Department of Energy, SBIR, which is the Small Business Innovation Research Fund, phase one grant proposal. It's like a 20-page long proposal that you have to write up with like a very detailed budget and budget justification, and project narrative. And we submitted that a year ago, back when I was like, hey, I just met you, but there's this grant coming up and it'd be great to apply to, and like, let's test what the working relationship looks like. So we did that a year ago, and then we actually just resubmitted the grant because it had opened up again, and we were like much more prepared this year. But yeah, so we joined forces a year ago, and then in the past year, we've been working on getting additional funding, both from the government and then also a couple different foundations, and raising a pre-seed. So that's where we are today. And today we have a bit of funding to scale up our tech out of the Rutgers lab, because it kind of exists as a PhD student's thesis project right now at Rutgers, versus like a technology that is within our company's knowledge, and we can like replicate the research and be able to translate that outside of the Rutgers labs. So that's the stage where we're focused on, and figuring out like, okay, all the equipment is at the lab right now. We can make this tiny little sample puck. How do we make like massive slabs of it? And like, how do we find the equipment? How do we find contract manufacturers? And like, what are the key barriers to actually getting to a full-size prototype?
So super random, but have you heard of Streamline Climate?
Yeah, I'm good friends
Okay.
with Helena.
Okay, got it. She was one of our
Oh, really?
uh, first podcast interviewees.
That's awesome. Yeah.
And so yeah, it brought that to mind. Have you used the Streamline platform at all?
I've toyed around with the product a bit. We're a little early stage, unfortunately. That one caters more towards um, larger climate tech companies that have written several grants and can are going after like larger grants. But right now, it's mainly me and the CTO, just like hammering out grants. Like we only have a couple under our belt.
Vivs, we should start like a podcast tech licensing agreement where anyone on the podcast gets the other technology on the podcast for some discounted rate, you know?
True.
So how reliant do you feel you are on governments for demand for the product? Like it feels like, so let me ask maybe a more basic question and then the follow-up, which is, could you say a little more about the tech? So it's a climate
Sure.
reducing concrete. Is that what it is?
So it's a carbon utilizing composite material. Long term, we can replace like structural applications and um, say produce the material in generic sizes like 2x4s. And so builders can pick up
Hmm.
2x4s of our material at their local building material supplier and be able to put into housing frames or like siding or like decking, or
Mm.
just make it essentially a new raw material for the built environment.
Got it.
Yeah.
So we're personally doing a house reno right now.
Oh,
Yeah, I would love to have used material like this. This would have been great. But would it have
yeah.
been, in your opinion, let's say you're at some level of scale, maybe you have a manufacturing plant, is it a cost decision for me where I'm saying, actually, this could be a cheaper material, or is it maybe incentivized in some way by government grant money, maybe like a California low carbon fuel standard or something like that? How do you see it fitting into like a
Yeah.
market demanding the product perspective?
Yeah, that's a great question. Um, so long term, our main play is cost and performance. When I was doing my tech search, I was really specific in trying to find something that was a better product at lower costs. The
Mhm.
tricky thing is that there's a lot of like low carbon concrete alternatives, but they're selling into concrete, which is one of the cheapest materials in the construction sector. It goes for like $100 per ton, right? Which is
Yeah.
insane. Versus our product is this composite material. So it's a blend of ceramic and polymer together. So it's concrete like, it's like very strong. It's stronger than concrete, but it's also like 100 times tougher, meaning that it can have more impact to the material without cracking. And so we hope that by providing something that is tougher, more crack resistant, also fire resistant, um, and has all these other benefits, that we can convince customers in the construction industry to adopt it purely based on cost and performance. Um, and so that's our major play. And then something that's been interesting recently with all the wildfires is that our material is a fire resistant material. So if we can replace like wood construction as a new type of construction while being as easy to work with as wood, then we can have something that makes housing overall like more fire resistant and more durable. And that could be like a really interesting play to insurance companies then. who could provide benefits to homeowners that use our material or build with our material versus wood construction. Because right now wood construction is like, wood is like very abundant in the US and it's much cheaper than concrete construction because concrete is very heavy and labor intensive. So if we can create a new paradigm around like fire resistant materials, then we can actually have a lot of impact in the space.
So how many tons of material, like concrete, would you need to like build an average house? Because that it's $100 a ton. That's very cheap, right?
I'm not quite sure how much material you would need. Um, it depends, like, it also depends what application we're going after. Because the tough thing about a materials company is that there's like 100 different applications we can go after around like, do we make like framing materials or like do we make panels or do we make drywall or like all these different areas. And our challenge is like figuring out what is the initial market we should get into that doesn't take ages to get into because construction is a very conservative market where we can like show high margins. And so actually the first market that we're looking into is like countertops and furniture because there's no one blocking us from making like these types of products. And then long term, like we'll start figuring out like, okay, what are the structural properties of our material and how do we refine it such that we can enter like those like structural applications over time.
Yeah, I bet like, just as an example, like the number of, like just think of IKEA, right? Like how much like random material they're using, wood and other things. Like imagine if it was all of that was carbon reducing. That would be pretty big, right?
Yeah, yeah, definitely.
Well, how do you, by the way, just on the material science side of things, it's funny, you're like almost describing my career because I studied material
Oh,
science. And like
really? That's
when
so
you think
exciting.
about the things you could go into with a material science degree, it's
Oh,
like
yeah.
anything. So I was like in thermoelectrics, then electric cars, then in solid
Yeah.
oxide fuel cells, then solar cells, then plants. Then it's like, what, it's like there's no
Yeah.
prescribed path for a material scientist. Whereas like, or some materials product, you're
Yeah.
totally right. You could do anything with a fundamental material,
Yeah.
which is so interesting. But to Vivek's question, I was wondering, like, how do you think about wood as a sustainable building material? Because to me, to some extent, wood might be the best thing that nature has provided at capturing carbon into something and keeping it there for a long time. Obviously, if it burns, it goes back into the air. But would you consider wood like a neutral or negative carbon sink production thing, or is wood actually sort of a problem?
It's a really tough topic because um and I don't think there's like wide agreement within the construction and architecture community as to whether wood is good or not. It's definitely better than like concrete and steel today because concrete's like zero point 0.9 or cement, which is the core ingredient in concrete, is like 0.9 kilograms of CO2 per kilogram of cement, like emissions. And then steel is like probably 1.4. So it's like really high amounts of CO2 produced per ton versus wood is a bit trickier to figure out because while you have all the carbon going into the wood during growth, it's harder to measure the end of life of wood where does it get burned? Does it end up in landfills? Does it get recycled? Um, there's just not very clear tracking around that. And if it ends up in a landfill and is like mostly whole, then it ends up storing the carbon for a really long time, like 100 years plus. But if it gets ground up into mulch and used that way, then like the mulch deteriorates and then ends up emitting CO2 or like methane, which is even worse than CO2. And so it's just really hard to measure. But whenever you're dealing with a bio-based material, you always have all the issues around like rotting, molding, pests. It's an organic material, so it's naturally going to want to rot and go back into the atmosphere versus like anything concrete or cement. Um, your raw feedstocks are not organic or is not going to re-emit that CO2 back into the atmosphere unless if you run a reverse chemical reaction. So we know for a fact that the CO2 is stored very durably in our material versus like with wood, it's much more up in the air. I know there's like some really cool things happening in the mass timber space as well. And like architects are working on building higher with mass timber. And so it's really just like, how do we create a portfolio of different construction methods beyond just like highly emitting concrete and steel that work towards like more low carbon materials, mass timber, wood that doesn't rot, or like more ceramics that are made with low carbon alternatives. Oh, I think you're muted.
Oh, I'm sorry. I was just saying, I think you can play in the same markets even as like Heirloom, which we had on the pod,
Oh,
where
really?
you know you can
Yeah.
actually you can have payment for carbon capture the way that wood can't. So if those markets become more robust, then that becomes like a super maybe secondary revenue source, even to what you were
Yeah.
saying initially, where you weren't even, I think, counting on that. But it sounds like there's a lot of upside if those markets become
Yeah.
bigger.
Yeah, definitely. Yeah, I mean, our core business model is really just around like selling products in a profitable business model like outside of the carbon credits ecosystem. But there's definitely a play where it's like eventually perhaps we could subsidize even lower with the carbon credits ecosystem. But a lot of it's like, we use CO2. How do we incentivize the capture of CO2 such that it's profitable for like an industrial plant to capture CO2 and sell it to us, and we sell it into premium products, and just drive a very natural ecosystem around using CO2 into different products.
Is there anything you could show us or tell us about the material? Like, what does it look like? I'm just like in my
Yeah.
thinking, what is it all
I'm pretty sure I have a puck on me. It's like,
about? Oh,
it might be deep in my backpack. Oh no, I got it. Okay. I always carry this around. It's kind of an old sample. I got it like a year ago, but I always show it. It's like, it's kind of this thing.
mm-hmm.
It's so lab. Um, it's like straight from the lab, so it looks very like researchy. But this is like, it's a polymer ceramic composite, and so it's mostly ceramic material that during curing reacts with CO2 to form calcium carbonates, and the curing step also hardens it into this like really strong, durable material. And then the screw and like the little holes in there are to indicate that um, when you screw into it or drill into it or nail into it, it doesn't crack. Versus like, you can think about like a ceramic tile, um, and it just shatters. And so by
It's
creating
more.
things
Those
that,
are more brittle. Those are more brittle than this, which is. It
yeah,
seems to be. Yeah.
yeah. So if you introduce a lot of toughness and like the ability to machine a material like this, then you can reduce labor costs. You can reduce breakage during transportation. Um, you can introduce different fabrication methods. So, like I mentioned, like the wood-like machining makes it really easy for builders to cut, versus like stone or like ceramic or like tile, where you're at risk of like chipping or cracking or breaking the raw material itself. And so there's a lot of really interesting advantages to working with this material versus like a traditional like 100% pure play ceramic tile, or trying to replace cement, which is difficult. Yeah.
I was gonna say I could see it even being like potentially like flooring or
Yeah.
like things like that. Like, could you like stain it or like do something to make it look different?
Yeah. Yeah. It's pretty standard ceramic processing methods where you can pigment it, add in different colors. You can add like a surface um, pigment or stain as well. You can paint it. You can put a sealer on it. Those things are pretty straightforward or like off the shelf.
You were kind of alluding a little to the first play into the market being maybe a more, I mean, something a more like a chair or something in the household, something like that. What are you thinking? Do you have a thought on what that first product is actually going to look like?
Yeah, so we've done a decent amount of research into this, but we are most interested in countertops right now. Um, just because countertops sell for like to redo your counters in your kitchen could cost upwards of like $2,000 for like maybe what, like 30 square feet of material. And so if we can make the material at less than like $5 per square foot long term, then that could be really compelling in terms of like a high margin business, and showing investors that, hey, this is like a good core business, regardless of whether it's sustainable or not. It's just like cost effective, half the cost of competitors right now, and we can sell really quickly and sign on distributors really fast because of purely the cost and performance. And so that's the type of business and messaging that we want to get right with our first niche market. And then that will fund our ability to de-risk the manufacturing scale up of this new technology. At which point we can start thinking about like what are the riskier areas of construction we want to get into, like exterior facade panels and like structural applications, and start really shooting high for like where we can go within the construction industry. But again, because construction is so conservative, it's really important for us to nail it down really well with one low regulation, easier market before shooting high.
So you're someone with like a computer science background. You studied engineering at USC, like a typical Silicon Valley computer science or like a software startup would
Yeah.
look very different to this, right? So
Yep.
like how did you translate that into what you're doing? I think
um,
that's really fascinating to think about.
yeah, it's a really great question. It's definitely a lot, I'm not gonna lie. I think like when I first was starting out my journey, I was like, I'm way over in the deep end, and there's so many terms that I don't understand, like what are techno-economic analyses? Um, like
What
how do
are
I
techno-economic analyses?
Oh, techno-economics is very key if you get into deep tech, but it's like what are the per unit economics of your core product after
Hmm.
mapping out all the necessary inputs like feedstocks, capex, opex, just so you understand like if I make at scale or like even within each individual stage of scale up, like what is your cost of materials or like cost of your product, so that you can show like, okay, if I put X% margin on top, then I'm going to be cost competitive against like the competitors. And this type of modeling is you can kind of do it yourself, but you kind of need like a chemical engineer who can, like, if you really want to get into the nitty gritty, like size equipment, source suppliers, figure out like the price of energy, and put that all into a model to understand your economics. So that's something really important, and is like kind of core to like understanding your technology scale up. But yeah, so back
Things like
to
that. Yeah.
yeah, exactly, things like that. Like, how do you figure that out? Um, yeah, so when I first got started, um, it's just a lot of learning. Like you also realize how much learning you can get done in like 2 years if you just full time like spend all your effort on figuring out like how to do something like this. Like throughout the 2 years, I was like reading a material science textbook for a while just to like understand the core fundamentals. A lot of it is just getting like really great people around you on board. Like um my two co-founders are like incredible, and like one of them's been working in the ceramics industry for like decades, and the professor has started several companies in the past, so their like expertise is like insane. um and then also just like throughout this path, uh I've talked to so many entrepreneurs and like so many highly experienced people in the deep tech space that I can like email them and ask them like how they think about certain problems. And so like yes, I have a computer science background, but at the end of the day, it's like I have a background in product and computer science, but it's really just like problem solving and like learning ability. And so it's like if I can just work backwards from like this is the end goal, then like what are the next key milestones I need to hit within the next 6 months to a year so that I can raise the next round to de-risk this one part of the business. Um, and like what are the necessary skills I need to do that? So like sales, fundraising, like some core like core science knowledge, material science knowledge, a lot of knowledge around like customers in the industry and like talking to people in the architecture and construction space. So it's a lot of information, but you if you're very focused, you just learn it very quickly.
You sound like
My ears perked up when you said sales because that's
Yep.
kind of what I mean. That's what I do. But
Yeah.
again, yeah, this theme of like my background and experience has been all in like software, software as a service, fintech, uh, now more AI stuff. Like
Hmm.
that's kind of been where I've been. So I think that's like a very different to what you probably experience in your day to day in terms of sales.
Yeah, I would say I'm not doing like explicit like sales at this point. It's a lot of very early stage sales. like sales, meaning like customer discovery, understanding customers' problems. Does our solution map to their problem? Can I put together a sales deck and sign them on as a early LOI or piloter? And just
And is
like,
that where you're saying your focus right now is maybe on the more on the sales side is people oriented in, well, at least people who are in the kind of countertops type of space, like people who sell, I don't know, different materials for countertops, or
it's kind of two things right now. It's like finding the customers who would be an early piloter, who are willing to take a risk on a brand new material that we don't even have like a full size product of, and say like, we're interested, like we really need sustainable materials. We are innovation focused and we are willing to pilot with you. Like that's one angle. And then another angle is like the long term big volumes from like large B2B customers. So like distributors, manufacturers, like can we convince like a large I don't know, like prefab kitchen, or like modular kitchen company, or like a countertops company, or like a furniture company to want a sample of our material and put us into their product development lifecycle, and say they're going to order like X tons in the next 5 years. So it's straddling the line of like early piloters, so we can show the big B2B customers that there's demand for this, and then going to B2B customers and being like, we have something that could be really compelling that might be in the market in like so and so years. Um, so it's all just like startup chicken and the egg problems, and sales
yeah.
to fund like and
I
fuel like both cycles. Yeah.
Funny enough, I been working with a lot of startups in the last year.
Hmm.
There are these chicken and egg problems are the
Oh
same,
yeah.
right? But it's a little different on the speed at which the speed, like both in terms of competition can be spun up, as well as we can, on the software side. So it gives you kind of a bit of a moat when you have like these deep tech type of things, because it's like once you've got the IP and you've got an initial sense for where the demand is going to come from, and you've done like the hard groundwork, then you actually have a lead. Versus like,
Hmm.
I think in software, like nowadays the lead is like 6 months. Like
Mm. Yep.
we used to say like 2 years. Like if you build a good product, you have like a 2 year head start. Um,
Mm.
Nowadays it's like with all the tools on the market, you can just, I mean, anyone can code at this point with like Cursor and whatnot. So it's like, um, it's kind of crazy how fast paced it is.
Yeah. Yeah, that's fair. Yeah, I guess the nice thing about materials and like manufacturing tech is that it's both a blessing and a curse, where the timelines are like double the timelines of software, but also like not that many people are going to follow you. So like I don't see that many new construction materials startups that are anywhere remotely close to what we're doing.
What I've been in the space for a while in sustainability, and I feel like the environment has changed in a way that has caused the communication around this to be more focused on how you can just beat the standard product on price, how you can do better on, sort of the material construction, things like that, and shifted away from the sustainable, portions of it, or how it's better for the environment. And I feel like
Hmm.
through this conversation, I can hear you navigating that pitch a
Yep.
little bit. Um, how do you frame it when in your head when you're thinking about it? It sounds like initially you got into it because you do think climate change is a big problem. And do you feel like as a group we're kind of blunting our swords by not just being honest about, or more forthright about, this is also necessary and we have to do these kind of things, and couching the pitch in a way that's just more practical? Or do you think, look, that's the reality and it's the world we live in? And I don't know, how do you think about that balance?
Yeah. I think about it more of the latter framing you mentioned, where it's like we all recognize, well, a lot of people recognize that climate change is a major existential threat, but like just the way that our society is set up with like capitalism, we really need to be focused on like what is the best business case, such that we can both grow sustainable methods of manufacturing, but also just like be great core businesses. And I mean, you see that in solar now, where it's like solar is cheaper than fossil fuels, and that
Mhm.
is like the best case scenario you can get to for like every other paradigm of manufacturing. And we just need to figure out what technology is going to get us there, where it's not only sustainable, but it's like better and cheaper. And like we're really focused on like, let's just make a better and cheaper product. And then sustainability like is a cherry on top, and like is still core, like so core to our mission, but just not like our primary selling point, because that's just not the long-term bet, and it's just not like feasible in um a world where like we need cheap and affordable construction and housing, and that's always going to be like the most important thing to the industry.
Yeah, it's hard because you probably wouldn't have started this precise company if it wasn't for the sustainability
Yeah,
aspect. Although obviously
that's
the
fair.
benefits are great, and
Yeah.
it's like so true of everything that I've ever worked in also, which is I probably wouldn't have done that thing if it wasn't for the sustainability side. But then
Hmm.
partly I feel like you have to pitch the other side, so what you're communicating out is a little different than what the company was founded on. And I I do hope eventually that society comes to realize the risk that we're in a little bit more presently and starts to
Yeah.
truly value these things in a way they're willing to pay for. Because to me, the clearest example of this is like you can burn 100 pounds of coal into the air and you pay nothing for it. If you were to take that same
Hmm.
100 pounds of coal and take it to a dump, I'd have to pay dumping fees. So
Hmm.
why isn't there a restriction on us polluting the air and the environment in a way that's sort of unseen? And it's just we're not paying for the negative externalities right now that we're
Yeah.
producing.
Yep.
And so it's a little bit like all these technologies are having to swim upstream by like
Yeah.
cutting off one part of their benefit package and just presenting the side that's, well, I can compete against all these standard technologies. And the last thing, sorry, just that I'll say on that is I feel like a lot of these standard technologies are like freight trains. They've built up
Hmm.
momentum over a long time. They've built up manufacturing efficiency on a long time. You're having
Yeah.
to do all of that from scratch. So
Yeah.
you don't have standard equipment. You don't have standardized production lines. Like that costs a lot. And so those
Yeah.
pieces of equipment
Yep.
and production lines and everything, in the beginning, you have to find these super niche applications that, to your point, are expensive to justify those production line bring ups. And we do need government, I think, at some level to continue to step in and play a role. Or if it just leaves the space, I just worry that companies like yours are just going to have a much harder time.
Yeah. Yeah, I totally
Sorry, that was a
agree.
diatribe and not a question, but
No, I absolutely agree. It's like we're going up against industrial processes that have been around for like 100 plus years, that have been optimized by like super smart engineers for the past 100 years to be the most cost effective and highest performing thing. So it's very difficult for sure. Um, and I do agree that like government has to step in, but it's like it's one of those things where it's like it's not within our control to force government to like price these negative externalities into our economy. So it's like in the absence of that, like working within these constraints, how do we still make progress even though it's like really hard? Um and maybe eventually government will catch up, but like who knows, you know? But yeah, I agree.
the practical CEO answer to my question. I think that the reality hitting. Yeah.
Exactly. The reality hits. Yep. Yeah. Do you work in the sustainability space? I know we didn't
Yeah, yeah,
get
we
to.
I work in sort of sustainable agriculture right now.
Oh,
Yeah.
that's awesome.
Yeah. Yeah, I think like it's still, I mean, I will always try to work in the space because I feel like to me the problem feels pressing and important enough that I want to continue, and I do feel like people will catch up to feeling it. And so the blips in the middle, like I feel like we're in a little bit of a down blip in terms of people feeling of able to talk about it, but those feel like blips to me compared to the overall trend, which is just it is something I think we have to solve and it's worth working on. And yeah, I don't know. There's nothing else, I guess. It does feel like there's headwinds right now though.
Mm, yeah.
Yeah. Oh, Vivs, you're muted.
I was just going to say, I, on the other hand, I'm in a very carbon producing industry with LLMs and like AI.
Oh yeah.
So it's it's a little different, but I think that uh, Helena made a really good point on the podcast where she said capitalism will sort of figure that out in some way, whereas I think the government intervention side, like, it's just like Microsoft going and buying through Mile Island, like for nuclear power plant, like those kinds of things, versus other parts of the economy, like coal, right? Like, what are you going to do? How are we going
Yeah.
to? The economics are just like the negative externalities are not posted. So,
Yeah.
And in
Yeah,
many
definitely.
cases have been subsidized for decades themselves. So, and or some
right.
cases are still subsidized. Well, Teresa, did you want to end us on any specific note? Tell us about anything unique, or maybe
You
on your
guys have
journey,
anything coming
something.
up? Yeah.
Yeah.
Let's see. Well, we should, we're producing samples, like we're reaching our next level of scale up, which is kind of like sample tiles that we're really excited to show to customers. Because right now we have this like tiny little like circular puck that doesn't look like anything. So once we have these tiles, it'll look like much more catered towards like a product. And I'm like really excited to share that with our early supporters and customers in the construction industry and just, get going. So I'm super excited. But yeah, definitely like it's definitely a challenge, but it's one of those things that like feels very worthwhile. And I will say like my favorite part about the climate tech ecosystem and the deep tech ecosystem is like everyone is just like so wildly um, resilient and supportive and willing to share information and just mission driven that like it's just very heartwarming to like be surrounded by these people and like to work on problems that are of this magnitude and you all feel like this similar challenges, but you can all like learn from each other and everyone's very open. So yeah, I'm having a great time. Despite the struggles,
Super
I'm
cool.
having like a lot of fun. Yeah.
Super
Yeah, that's
cool. Yeah.
awesome. Yeah, thanks for taking the time with us today. I mean, it was awesome learning about your company and how you got into it. And honestly, I think we both wish you the best of luck. We really want this kind of thing to succeed. So let
Thank
us know
you.
if we can help in any way. Yeah.
Yeah.
Yeah,
And
of
we should
course.
talk. We're happy to talk again whenever, if you ever have like something more to share or anything like that, feel free to reach out to us. We're happy to chat.
Yeah, of course. Yeah, thank you so much for hosting. I'm really, I always get really excited when people kind of like elevate different climate tech solutions, and there's just so much to learn in this sphere. But I'm like happy to answer any additional questions, or if people want to reach out to me, you can drop my contact in the post, and I'm happy to help support the community.